Hello students, welcome back to my channel. I am again here with a new video in continuation with the previous videos. We are discussing questions which were asked on 2022 Neet exam. So continuing with the same previous videos, you have the graph which shows the variation of de Broglie wavelength lambda of a particle and its associated wavelength. Now whenever you have to get the graph between two quantities, just write down the mathematical relation between them. That will be the first step. Okay. So de Broglie wavelength and momentum. You know de Broglie wavelength is given by h by p, where p is the momentum. And since h is a constant, we can write that lambda varies inversely as momentum. So when two quantities vary inversely with each other, students, the graph is a rectangular hyperbola. Rectangular hyperbola will touch the axis at infinity. Okay, so second option is the correct option. Then moving on to the next question, question 43. In the given nuclear reaction, the element exists. As you can see, this is a positive beta decay. Basically, it's a positron. So this is a positron. Okay, a positron is a subatomic particle, very much identical to electron, but with a positive charge, equal and opposite to that of an electron. Mass and everything, all the other properties of positron is identical to that of an electron, with the only difference being the nature of charge. Electron has negative charge, positron has an equal but positive charge. Then this is a neutrino. Okay. So basically what happens in a beta decay, we all know that within the nucleus, either a proton gets converted into a neutron or a neutron gets converted into a proton with the release of a positive beta or negative beta particle. So here in case of this positive beta decay, a proton gets converted into a neutron and a positron. Of course, the mass of neutron is more than mass of proton. So how does the mass increase? Of course, at the expense of the overall mass of the atom, I mean nucleus. At the expense of the overall mass of the nucleus, the mass of this product will be more than that of the reactant. Anyway, that is a separate matter, leave it. So for now, you can see. So since one proton is destroyed, so certainly what will happen? The atomic number will reduce by 1. So for this x, the atomic number is now 11 minus 1, that is 10. Okay. So based on this, 10 means 10 stands for neon. Atomic number 10 is for neon. Then now what happens here? As you can see, students, there is an increase, there is no net change in the number of nucleons because one proton has vanished, but at the same time one neutron has emerged. So the total number of nucleons remains same. So this will remain unchanged. So this will remain as 22. So correct option is the first option, neon. Moving on to the next question, let T1 and T2 be the energy of the electron in the first and second excited states of hydrogen atoms, respectively, according to Bohr's model of an atom, the ratio. Now, as per Bohr's model, the energy associated with nth orbit for a hydrogen atom is minus 13.6 electron volt upon n square, where n is the principal quantum number. So we can write that the energy related to nth orbit varies inversely as the square of the orbit number itself. So we have T1 by T2 is equal to n2 by n1 whole square. So what is the initial orbit number? Initial orbit number is the first. So this is 1. But sorry students, they are first and second excited states. So first excited state would correspond to the second orbit. And second excited state would correspond to the third orbit. So this is 9:4. So correct option is the first option. Sorry, second option. Then moving on to the next question. When two monochromatic lights of frequency nu and 2 nu are incident on a photoelectric metal, their stopping potential becomes Vs by 2 and Vs respectively. The threshold frequency for the metal is. Okay. Now here we'll be using Einstein's photoelectric equation, which states that total energy of the photon, which is completely imparted to the photoelectron, is partly used in freeing up from the clutches of the different bonds present on the surface. So all these things would mean spending an energy, minimum energy equal to the work function, and the rest is stored in the form of kinetic energy. It is this kinetic energy which is actually the also equal to the E into Vs, where Vs is the stopping potential. So the maximum kinetic energy is equal to EVS. Sorry, and E is h nu. Sorry. So as per the question, uh, according to the question, let us write what is given. When frequency is nu, the stopping potential is Vs by 2, Vs by 2. And when frequency is 2 nu, the stopping potential is Vs. You have to find the threshold frequency. Now, threshold frequency can be written as h nu naught. If you take the threshold frequency as nu naught, then you know work function is h times of nu naught. So I have to replace these work functions with h nu naught. H nu naught, here also h nu naught. We have to find nu naught. So for that, we can we have to eliminate Vs here because the options are in terms of nu. Okay. So from equation 2, I can write EVS is equal to H into 2 nu minus nu naught. Whereas from equation 1, I can write E into Vs by 2 is equal to H into nu minus nu naught. So if we divide, then we have H into 2 nu minus nu naught is equal to twice h into nu minus nu naught. Okay. So here data is, we'll get some data which is absurd. For example, 2 nu minus nu naught is equal to 2 nu minus 2 nu naught. So nu naught is basically 0. So there are no options. So anyway, something is wrong with this problem, student. Okay. In other books and all, if you search, they are telling that the data is inaccurate. So students got bonus marks in this. Okay. All right. We'll move on to the next question. A nucleus of mass number 189 splits into two nuclei having mass number 125 and 64. The ratio of radius of two daughter nuclei respectively is. So since we want the ratio of radius, nuclear radius is given by R naught into cube root of mass number. Since mass numbers are known to us, it's a matter of taking ratio. So the ratio of the radii will be cube root of the ratio of their mass numbers. That's all. So what's the mass number of the first? It is 125. And for the second it is 64. Okay. So 125 can be written as 5 into 5 into 5. 64 can be written as 4 into 4 into 4. So if you extract this cube root, you get 5 is to 4, the first option. That's all students in this video. Thank you so much for watching.